Okay, welcome back to the next part of the video. In this series of videos, I'm going from Earth to Mercury, and I'm going to use the HCLV launcher by LaRue. It's a very cool launcher. If you haven't checked this out, you should download it for sure. And we're going to use this launcher to get the XR2 into orbit. At least I think we're going to use the XR2. I'm not 100% certain on that yet because of the tremendous fuel cost of this mission. So that's what this part of the video is going to be about, is going to be figuring out fuel costs and requirements to see if we can actually get the XR2 to Mercury or not. And if not, we'll have to use a different vessel. Okay, so let's start off by putting another XR2 into orbit so that we can see what the what the DV is when we're in the vacuum of space, because we're not going to be using the XR2 engines until we're in space. Okay, so now we've got an extra XR2 in orbit. So let me select that vessel, and let's get inside of it. And let's bring up a burn time calculator. And we have a total DV of 12.396 kilometers per second. Now let's fill it up. Obviously we're not going to have enough locks with just one 14 days of locks obviously isn't going to cut it, so we're going to have to add in some more locks. Let's go to the payload camera, and we're going to take the crew habitat module with us, because even though it'll reduce our overall DV. So we put the CHM in, and we need a locks container. I don't know if a half locks will cut it.
Full.
And a main fuel. Okay, now let's see what that does for our DV. Of course, it's going to initially say that it's lower because it doesn't take into account the extra fuel mass. So the extra fuel mass is... can't ever remember that number. $3705.2 minus the weight or the mass of the container, 3350, plus 804 of RCS, because we won't really need that much RCS, so most of the RCS can be transferred if necessary. So that's 4154 of extra fuel mass. So let's punch that in, set that aside. And we're still pretty low. Okay, so let's see what we can do about getting rid of some crew. Can you edit crew from this? I don't see any way to do that. I don't really know the sequence here for these. Let's see. Is it inner door, chamber pressure, then outer door, or is it chamber pressure first?
Airlock depressurizing. Airlock pressure 0 psi. Warning, nose cone is closed. Outer door is locked. Warning, chamber not pressurized. Inner door is locked.
Okay.
Warning, outer door is closed.
Okay, so chamber or nose cone, chamber pressure, outer door. That's all right. Let's get rid of the crew.
Egress successful. Egress successful. Egress success. Egress success. Egress successful. Egress successful.
So that we have 6 left now.
Egress successful.
Okay, that's That's 1, 2, 3, 4 left. Let's see if we can just do
Egress
3 crew.
successful.
Okay, so we have 3 crew. How much locks does that give us? 1,014 days. We don't need that much.
Locks tanks full.
So 65 days with 3 crew. How long is the trip going to take to get to the surface? It doesn't take long to get to Mercury. If you do a direct flight anyway, like we are. So we're saying that we're going to leave 51309 and we're going to arrive. Actually, I need to do that the other way around. Okay, we're going to arrive 51406. So we can leave, we're leaving 51309. We need 97 days, so we're going to have to get rid of 1 more crew and just take 2 crew with us.
Egress successful.
Okay, with 2 crew, we have 98 days each. That's really pushing it. 98 days, 7 hours, 13 minutes. Well, okay, let me check the numbers again on the launch, on the transit time. Okay, so if we leave 51309, no, let's say, okay, let's say we're going to arrive 51407. Let's just estimate 1 day high. And we leave 51309, so that's 98 days. I don't like the idea of just taking 1 crew, or 1 member. Well, I think we got enough. I think we can take 2. Okay, so 2 crew members. It's cutting it really close, but I think we can take 2. Now, let's see, we won't need any scram fuel because we are... Yeah, we're going to do a vertical launch, so we can dump all the scram.
Warning, fuel dump. Warning, fuel dump. Warning, scram fuel depleted.
Okay, so with 2 crew members and a fully loaded XR2 with no scram, we have 16 kilometers per second of total DV. I just don't think that's enough. What if I dump the other crew members out of curiosity?
Egress successful.
Yeah, that doesn't really gain us hardly any DV. Okay, so, well, let's figure out exactly how much fuel we're going to need from low Earth orbit. Because remember, the ride to orbit is free, basically. And technically, we'll arrive in orbit and we'll have some fuel left over. Because the HCLV won't require, we won't use all the fuel in the HCLV to get it, just to get to orbit. We'll have some left over, probably quite a bit. So I could use the HCLV to start the ejection burn for going to Mercury. See, I estimate that this trip will need at least 16.8 kilometers per second. And we're not quite there. We're really close. But I do think that with the fuel that I'll have left over in the HCLV, it'll be more than enough. And I can't really think like what other vessel can I use, because if I can't mount the XR5 to the HCLV. It won't work. It'll look stupid for one thing, and I don't think it has the lifting capacity. Could take the Delta glider, but not real keen on that, because it has, basically almost like infinite resources, it seems. You can take the Delta glider off from the runway and fly it to Mercury. So I think what I'm going to do then, I'm going to take the HCLV, and I'll just, whatever fuel I have left over when I get into orbit, I'll keep it attached to the XR2, and I'll start the burn to go to Mercury, and then just detach halfway through the burn, I guess, and do the rest of the burn with the Raven Star, which that's kind of weird, but I think I can do that. Alright, so what do I need to do then? Let's Control F4. Actually, everything's fine here. Let me exit the scenario and start it back up. That way I can get rid of the extra XR2 that I put into orbit. That's not what I want. This one. And since I got time left, if I can, I'll go ahead and start the journey now. Actually, before I do that, I have to edit this XR2. Yep. Okay, so I need to edit this XR2 so that it is appropriately configured. Okay, CHM. And what we do, half locks. Actually, do we need any locks? No. So, that's the wrong one. XR2 main fuel. XR2 main fuel. Yeah, if I put 2 main fuels in, that's actually scram fuel. What if I put 2 main fuels in? So now we have 3350 times 2. And then I get rid of all the scram, obviously.
Warning, fuel dump. Warning, fuel dump. Warning, scram fuel depleted. Using external O2.
Okay, so I get rid of all the
External
scram fuel.
cooling
I have
online.
double main fuel. Now I need to get rid of the crew. There's no way to edit the crew, I don't think, so I'm just going to have to Control S to save the scenario, exit out of orbiter. Close that out, and have to shut down orbiter because I'm going to have to edit the scenario and move it. Okay. Just doing a bit of file management here on my other screen. Just give me 1 second. So that's going to be... Let me edit this file. And delete those crew members. Okay, let's see first of all if we can just delete that many and take 2, because I would like to take 2 if I can, but I don't know if I have the locks for it. So let's save that. Let's reopen orbiter. And if if this will work, then we'll have plenty of fuel, because I think before, when I had the XR2 in orbit and I was looking at burn time calculator, I'd only added one extra fuel. So with this one,
Welcome aboard, Commander. All
yeah.
systems nominal.
So just
External
with the
cooling online.
just with the cabin oxygen, we have 98 days, which is really pushing things. But you know, I'd rather do that and have you know, 2 crew members rather than have 1 crew member and have 180 days of oxygen or whatever. Well, actually probably be twice that much. So yeah, about 180 days. So now I've got 2 external fuels. So 3350 times 2 plus 804, 7504. But this doesn't take into account, I mean, this is because I'm still in the atmosphere. So, okay, yeah, I've got it. The bottom line is I've got enough fuel. Okay, so let's finish setting things up then. And here in stage 1, we need to do our usual escape plan stuff, bring the PE distance down so that it's just 200 greater than that number, so 6571. And there it is. Now find the right eject orientation to use. Let me actually change setup to view plan. Okay. So we'll get a heading of 117 if we leave right now. We want a heading of 90, so we need to leave sooner than now. So let's actually back the date up just a tad. Let's go back a bit farther than that. Go back a bit more. Yeah, about right there. Maybe a few more minutes. Yeah, right there's good. Yeah, we got a heading of 90 degrees right now. Okay, now let's check the grocery list to see if we're forgetting anything, and then let's go. Alright, I can't think of anything, so let's just do it. Alright, let's go with, let's try the... Yeah, why not? I never get to use autopilots. Let's try the autopilot. Or the auto launcher. We're just going to set for 200 kilometer target APA. Target heading is, yeah, 90 degrees. I think that's everything. Launch. Try out the new HCLV autopilot launcher, see how it works. hands-free. We should be able to get to orbit before this video needs to come to an end, because I'm only at 20 minutes at this point. Alright, now as we're on our ride toward orbit, I don't know if I can make any adjustments here or not. I might have to wait till I'm in space. But I can see that my relative inclination is getting gradually worse. I would normally like to yaw the vessel a little bit at this point. But I don't think I can really do a change here now that I'm already on my way to orbit. Guess maybe I can a little bit. It doesn't seem to be tweaking the autopilot too bad. Just like to keep my relative inclination good and low. Just have to be careful doing adjustments while some kind of autopilot is running, because it can tend to mess up the programming. This launcher is really good. I love it. Okay, let me tap a little bit more yaw, see if I can prevent the relative inclination from just getting completely out of control. Yeah, the autopilot's definitely fighting me. Yeah, one thing I wish autopilots had would be like a release yaw or release pitch or something like that to let me control the yaw. I guess you can't really do that. I don't know. Well, at any rate, it looks like we're going to be 1 or 2 degrees out of plane when we get into orbit, so we're going to have to do a correction. I guess I should have done the launch manually after all. But I just wanted to try out an autopilot. I don't ever use these things. Oh, boosters fell away. I missed that. It's a really cool animation when they separate. Yuck. I wonder if I can just kill the autopilot altogether. I don't know. AP status active. PLV, what's that? I probably just screwed everything up, I don't know. Yep, I totally botched that. I just completely separated the XR2. Okay, let's start over. I'm not a fan of autopilots. In fact, let me just go ahead and end the video here, and I'll pick up in the next part, and we'll start the launch over, and we'll do it right. If you like this part of the video, go ahead and hit the like button, subscribe to the channel, check out my Facebook page, and I'll see you in the next video.